Okay, so this is the solution, the general solution for differential equation with two different roots. So we just put the two different root over here, the square of the exponential. Okay, the power of the exponential, sorry. Okay, so now we want to find the general solution when we have a non-homogeneous question. So we will have two components, which is particular integral and complementary function. So we have known our particular integral right here. So we just add the particular integral with the complementary function right here to get the general solution of the differential equation. Okay, so you just literally add this function with this function, you will get the general solution. Right, so just you can try that and put the answer right here. Okay, so now we go to the next example. Find general solution of d2x dt2 plus 5 dx dt minus 9x, and now the right hand side is cos 2t. So if you remember, this equation is exactly similar to example 10.40. So if you look at here, this is the same, plus 5, negative 9. Okay, so plus 5, negative 9. So since we know the left hand side is the same, so we can use the similar answer for the complementary function. No, sorry, the general, yes, complementary function, yes, exactly. So we can use the complementary function equal to this one. Okay, so you need to bear that in mind. So right now we want to find the particular integral. So we look at the right hand side, which is cos 2t. So whenever we has trigonometry form function at the right hand side, we can use a trial function, different trial function, which is like this. So p cos 2t plus q sine 2t. Okay, so it depends on this what inside the cos. So we use the same value, and we has two unknown parameter that we need to find. So right now what we need to do is we want to substitute this one inside this equation, but we need to find dx dt and d2x dt2, the first derivative and the second derivative. So dx dt is equal to negative 2 p sine 2t plus 2q cos 2t, and the second derivative is equal to negative 4 P cos 2t minus 4q sin 2t. Okay, so we just put everything inside the differential equation. We replace it. So we substitute. So what we will get is quite a lengthy equation. 4p cos 2t minus 4q sin 2t plus 5 negative 2p sin 2t plus q 2q cos 2t. So you can write it down properly, do not make any mistake. P cos 2t plus q sin 2t, and this all is equal to cos 2t. So we make the same, we use the same method where we compare the left hand side with the right hand side. But before that, we need to simplify this equation. So when we simplify, negative 13p plus 10q. So we simplify it according to the cos 2t minus n sin 2t plus 13q sin 2t is equal to cos 2t. Okay, so now we compare since the right hand side we only have cos 2t, so we consider the cos 2t at the left hand side. So from there we can conclude that negative 13p plus 10q is equal to 1. Okay, and we also have another equation from this comparison, so which is p plus 13q is equal to 0. Okay, so from here we can find the value of p and q, so you can calculate it, and we will get that p is equal to negative 13/269 and q is 10/269. Okay, so since we have known this constants, so we put this back inside this solution. This is actually a solution. So we put this value inside that equation, so we will get the particular integral. So xt is equal to, so we put the value of p and q, so we will get negative 13/296 cos 2t plus 10/296 sin 2t. Alright. Okay, so we obtain the particular integral. So how to find the general solution is by adding particular integral with complementary function. Since we have known the complementary function in the previous example, so we just add with this new particular integral. So again, I recall this is the complementary function that we will use inside this 10.41 example. So it will be the same function. So from there we can get the general solution, right? So that is for question with the right hand side is in form of trigonometry, which is in sine or in cos form. But if it is in tan, it will be different problem, but we will not consider that. Okay, so now we will go to the next example. We want to see what happen if the right hand side is in other different form. So we go to the next example straight away. So example 10.42. So find general solution of. So again, in this example, it used the same function, the same differential equation at the left hand side. So it is easier for us to get the complementary function. We will use the same complementary function, but the right hand side is different. So in this case, it is exponential. Okay, so how do we want to solve this? Again, like previous example, we make the first step is to find the trial function. So the trial function is based on the function form at the right hand side. Okay, so we find the trial function. So whenever we have exponential at the right hand side, the trial function is pretty simple. X is equal to P E for T. So again, I just want to explain that the trial function is actually the solution of this differential equation, but not the general solution, but the particular integral. Okay, so since we know the trial function, we find the dx dt. Pretty simple. And also the second derivative. Okay, so easy. So we just put everything back to this differential equation. So we will get this function. Okay, so this is pretty simple to compare because we only have one constant, which is P. So what we will do is we just add everything and we can find the value of P. So when we add everything, 16 plus 20 plus 9, minus 9, sorry. So we will have that 27 P E power of 40 equal to E 40. So we know that P is equal to, so we can cancel that out, equal to this one, 1/27. So we can get that from this equation, we can get the particular integral, which is x t is equal to 1/27 e power of 40. Okay, so and again, since we get the particular integral, so since we know the complementary function, we can just add the particular integral with the complementary function to find the general solution. Okay, but if the differential equation right here is different, you need to find again the complementary function. So hopefully you understand that. So before we finish, I want to show you something. So this one. So this is the formula. This is table 10.19. So whenever you find the right hand side, so this is the right hand side. Wait, okay. So how to edit this? So this is the, okay, I'll show you with this. So this is the right hand side function. So the left hand side is other differential equation function, which is you can solve it to find the complementary function. But the right hand side is for you to find the particular integral. So to get the particular integral, you need to you need to identify which is the correct trial function that we must use. So if the right hand side function has this kind of function, which is cubic, so the trial function should be in cubic form as well. So in this case, we has 4 coefficients that we need to solve, we need to find. Okay, so if the right hand side is a quadratic function, which is t is the biggest power is t power of 2, so the trial function should be quadratic as well. Okay, so this is the first one. So the second one is if the right hand side is exponential in exponential form, so the trial function should be like this, where the value beside the t is the same with the function given at the right hand side. So in this case is -3. So we will have p e exponential -3t. Okay, so only one function, only one constant that we need to find. And again, and the last one, if the right hand side function is in trigonometry form, but actually we exclude the tan, so we only consider sine and cosine first only. So therefore, this is the trial function that you can use to find the particular integral. So if you look at here closely, the value beside t is 5. So the value inside here, inside this function, beside t is also 5. So make sure you have that correct. And we only have 2 unknown that we need to solve. So I think that's all. That's all for